For a real number, equal, so real number, different from zero. Uh, yeah, so let's say for real number, we can define and denote, we can define the product. We multiply a by itself n times. N is an integer. Okay, n times. So this number, the resulting number, will denote it a power, well, power n. We, yes, and n is an exponent, an integer exponent. Okay, so n here is an integer. So let's write it on the other side. So for a real number and n belonging to the set of integers. Okay. Um, so this is, now we have for a different from zero, specifically a different from zero, we have a power zero is one, and then yes, we can establish. Um, we, so from the definition, then we can establish many properties on um, exponents. We call them law of exponents. Okay, so we have then the follow. I will just write some of them. Okay, you don't have to memorize everything. So, but the good practice allows us to think about them and use them well. Okay, so then we deduce then, for example, a negative n, okay, is 1 over a power n. Uh, the power, if you take a quantity to power n, either you see here, either positive or negative, you can deal with numbers, any number, with an integer to the power of an integer. So it will be the sum. If you have so they are connected, there's relations. Okay, we combine and we establish other formula. Okay, so it's we can write it as a power m minus n, for example. But mainly we need this to a m to the power n will be a, the product. There's two. This one you separate, multiply. This one the same quantity to a power, take it to another power. It's the product. So mainly this is what, yes, we have. If you have two quantities, different quantities, and you see them to a power, taken to a power n, then it's similar to a power n times b power n. Again, here we are using the definition for the product AB, using commutativity of the multiplication. Commutativity means I can move the terms in my product. I can change the place. Okay, associativity also, we can change the place. Okay, a over b, everything power n is nothing that a power n over b power n. You can separate. Okay, so just come back to the definition if you forgot anything. Okay, now let's then practice some kind of questions related to powers. Okay, the first one, for example, asks you to write, simplify your expression without write in form of power. Okay, so first kind, write in form of a power, depending the expression they are giving you. Here is the first one. The first one, 3 a power 3 to everything minus 4. It could be a specific number. So here it's more general, it's not fixed, but you can have to deal with just numbers. Okay, so so they are asking to write it in form of power. That means a number, for example, simplified form will be a number and a to a power of something. Okay, so let's do that. So which property, for example, we will use here? So I see here I have three, it's a term and another term everything to a power. So I would use this one, EB to a power. Okay. So then I can separate. That means I can separate here. So it will be 3 power minus 4. Okay. And E power 3 to power minus 4. I can do that. Okay. We can separate. And here can be negative. Okay. Integer or negative. Um, yes, as long as E and B are different from 0. Okay. So let's continue here. Yes. Now, a number quantity to power minus n. So I will use this one. So it will be 1 over 3 power 4. Okay. And then here, for example, so here, power to everything to power. So I am here. I can use this one. So it will be a 3 times minus 4. Yes. So I will have 1 3 power 4 and a minus 12. And then 1 over 3 power 4 times, so minus, and we said 1 over. You see how you can do things step by step. And like that, so they said in form of power, so I would leave it like that. Okay. Okay. I think I will leave it a power something. So no need to use this step. Okay. Here it is. We can stop. You can, of course, compute the number 1 over 81 if you want. Um, okay, let's do one more. One more. Continue. Yes, the same. This time, for example, they give me minus. It's more almost similar, so we will do it quickly for this one. Look, more 4. So similarly, a quantity times a quantity, everything to a power. So it's the first quantity to the power times, I can separate a minus 1 to the power. Then here, so it will be 1 over minus 5 to the power 4. And for this one, it's a times minus 1 power times minus 4, which gives me then here 1. Here I can also separate. Minus 5, I can see it is minus 1 times 5. So why you will see it is helpful to, to eliminate this minus 1. Compute it. It's much easier than computing 5 to power 4. And here you have a power 4. Okay, multiply. So you have here finally 1 over 5 power 4, because minus 1 times minus 1 is 1, minus times minus 1 times minus 1 is 1. Okay, a power 4. So it's similar. What about now this term? This one is, the expression is more complex, but let's follow the rules. A 1 over 3, a minus 2, everything minus 1 over a power 5. So they combined here many things. So let's go slowly. So here I can first work on, okay, so I can, yes, I can say I have a 1 over 3 in my, separated, okay? Uh, yeah, let's do it before that. I can, so there isn't only one way to start uh, to, to work. So just choose the shortest way and the most comfortable way for you. So it's 1 over 3. I can say minus 1 times, I separate my product, my fraction, like I see it like a product. Okay. Then here I work on the first term. I have minus the inverse, or I can see it as power minus 1. So I can separate. I have a product. I can do that. A minus 2 power minus 1. And here I use this formula, 1 over a power n. It's a power minus n. Okay? So that I see already the terms, or I can regroup my terms in a with power a. Okay. Then here, so here also I have like 1 over b power n. So I can say it's 1 over, or Yes, or negative, that means it's 1 over. It's 1 over, okay, minus 1, it's 1 over the quantity. So it's 1 over 1 over 3. Okay. And here then, here you have the product A minus 2 times minus 1. And here A minus 5. Okay. And now here you will get 3. It's like you are dividing 1 over 1. So you multiply, it's 1 over 1 times the inverse of your fraction. Here you will have E2. So you will have 2 and you add the powers. So we are using this formula now. 2 plus minus 5. And finally, I will get then the expression 3a power minus 3. Okay, so this is my simplest yes way. Yes, let's do now, for example, why if you are asked another kind of question, suppose that we are asked to simplify, okay, simplify the expression, okay. Suppose I am given minus 20 x5, several terms with powers involving powers and numbers, etc. 7 y7. Okay. Okay. So um, here, the first term, if I see it, I have a number x to a power y power. It's already simplified. I cannot do much for this one. This one also I cannot do. But now together I have a product. So I have multiplication, operation multiplication is commutative. So I can move terms and the associative. So I can, without keeping the order. So for me, what is important is that I regroup the numbers together and I regroup the x's together because then I can work with the powers, see if I can regroup terms or not. So I do the same for y's. Okay. Now I see that I have minus 20 over 5, it's minus 4. Here I can use this formula, a power m times a power n. So I will add the powers here for x. And also similarly add the powers for y. So finally I have minus 4, x12, y15. Okay. Let's explore another kind of questions for this one. Let's see this one, for example. Eliminate, for example, they ask you to eliminate a negative power. Negative power. So, for example, what if I am given this expression minus 4, y minus 5? Yes. So, yes, this one is almost like the previous example. So, I will regroup the terms, the numbers together, and the y's together, and see what I can do. So I will have minus 12 times y minus 2 plus minus 5, which gives me minus 12, y minus 7. Okay. So they want me to eliminate a negative power. So I have a negative power. So negative power, so it's 1 over en. Okay, so I can say it's minus 12 over y power 7. Okay, so let's do an example in the same kind of questions, but with more complex expression. So let's have, for example, y power 6, x power minus 10 over y power 7 and x power minus 9, everything multiplied by x power minus 11 over y minus 5, and everything power 3. Okay, then, so let's go slowly then. I can work, for example, with, for a moment here, I can work. So there is many ways to start working. So it's up to you. You can decide um, having something, everything, or one into one fraction, for example, or simplify this term first, simplify this term, then simplify at the end. So there are many ways. Okay, so let's do maybe simplify. We will get simple small powers, numbers, why not? Okay, so let's work inside each fraction, and for this one, we have a product. We have something like that, e over b power n. We can separate the powers. So I will have, maybe, yes, I will do this. I keep the first one, okay, over y7 x minus 9. And then I work on this one. So I will have x power 3 times. So I will have x 3 times minus 11 over y 3 times minus 5. Okay, so I will have finally the fraction y power 6 x minus 10 over y power 7 x minus 9 times x power minus 33 over y times minus 15. Okay, okay, so let's group the x's and the y's, for example. Why not? Yes, why not? So I will have y6 over y7 and multiply. Okay, denominator with denominator, uh, and separate. We can move. Oh, okay, yes, we can. We know how those operations. So minus 15 times. I can say, or you can keep it under the same. Um, but we will see what we can. And times x minus 33 over x minus 9. Okay, so here then I will have, um, so I can decide to do something like that. So y power 1 over, because this expression is, so I want to show you just something. So I can say it's y power 6 times 1 y7. Okay, 1 over y minus 15, I can say that. And similarly, times, uh, so 1 over x minus 9, and the other terms in x minus 10. So I can add those two powers. Minus 10 minus 33 will be minus 43. Okay. Okay, so just to have room here. Why I did that? To show that I have something 1 over y power n, so it will be minus n. So I will have y power 6 times y power minus 7, and I have also y power minus 15. Okay, and do the same for x. X, I will have x power minus 9, and then x times x minus 43. And then here I can add the powers. So I will have uh, 6 plus minus 6, 7 minus 1 plus 16. I will have then 114, power 14. Here I will have 9 times x power 9 minus 43. So it will be negative. We want, we don't want a negative power, so we'll put it down in the denominator. So I will have an expression over, so 9 from 13, it's 4, 40, 34. So we will have 34. Okay, that is, yes, my answer. So it's not the only way to start the work, but yes, just be careful on how to use those rules. Okay, so mainly this is based on the definition. We establish these properties. Okay.